This system contains a supply tank, which distributes fluid by means of a three-phase pump to a return tank. The return tank has a single-phase pump to return fluid to the supply tank, creating a closed-loop system. A flow meter is in line with the flow to allow the user to determine flow. A differential pressure cell is fitted below the return tank to allow the user to determine height of water in inches of water.
For the closed-loop fluid distribution system, we're using a CompactDAQ. The CompactDAQ consists of a NI 9474 digital output card, digital output 0 for single-phase pump operation, digital output 1 for three-phase pump operation, a NI 9203 analog input card, analog input 0 for a flow meter, analog input 1 for a DP cell, a NI 9265 digital output card for operation of a VFD, and analog input to control frequency to the three-phase pump.
This closed-loop fluid distribution system, we are using a NI CompactDAQ as the controller. This NI CompactDAQ requires LiveView to be programmed. LiveView consists of a front panel and a block diagram. The front panel can be closely related to an HMI as it allows for a visual representation or visual interface when controlling your system. A block diagram can be closely related to a back-end code that you would see when building a website or something along those lines. This front panel has a set of digital inputs and outs and analog inputs and outs. Auto mode is the button on the left. This controls a function, the PID function, to go in between automatic mode and manual mode. Within manual mode, you can decrease the tank level by using the single phase pump, and that is labeled as decreased tank. Increased tank level controls the three-phase pump. That is a range from 4 milliamps to 20 milliamps. As you can see, we have a supply tank level that shows our supply tank level in ranges of inches in H2O. We have a return tank level, which that shows our return tank level in inches of H2O. We have a variable input that allows us to adjust the tank level within our return tank, and that can be set all the way up to 30 or 0. A supply pump status, that indicates if the supply pump is on, which the supply pump is the three-phase pump. The return pump status indicates that the return pump is on, which is the single-phase pump. Time remaining until set points had reached, that is a countdown time. PID control data, that is a waveform that will show the tank level set point, the tank level, and the controller output in real time. PID control, that is proportional gain control, integral time control, derivative time control. That is our PID function. We're only utilizing the PI portion of it, so it would be a true PI control instead of a PID.
The front panel for the closed-loop fluid distribution system contains a supply tank and a return tank showing tank level and inches of H2O. Status indicators are shown on the front panel for the supply pump and return pump. The supply pump for increasing tank level and return pump for decreasing tank level. In auto mode, the user can enter a tank level set point. And notice that the return pump status indicator is turned on and the level of the return tank is decreasing to the desired set point. In manual mode, the user can increase the tank level by sending a current signal to a VFD that determines the frequency being delivered to the supply pump. The user can also decrease tank level by selecting the decrease tank level switch, applying power to the return pump.